All right, let's talk about chapter 8. And chapter 8 was all about this idea of confidence intervals. Right, so now confidence intervals. So we talked real briefly, confidence intervals. What is it? It is me going into a population, right? Let's say I got a population, and I go and take just a part of the population, right? We call that the sample. And then what we do is we extract a statistic out of the sample. In this case, we're either going to be doing X bar or P hat, right? Those are the two different styles that we're going to do to pull out of the population. And what we're hoping is that the X bar will tell us the population mean, or the P hat will tell us the population proportion, which we just usually call P, or some textbooks like to call it pi, right, to keep it with the Greek symbol orientation, if that. So again, here's what we have. We have the sample stuff. What we want to know is the population stuff, right? So what we're going to do is try to give our best guess for that. Now, a lot of times that means that when I go into a sample, I'm going to get different values every time I take a sample. So instead of just relying on my one X bar value and saying, okay, here's what I think it is, no, 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 no. We are going to extend up and extend down, and we're going to create an interval of values that will have a lower bound value, it will have a upper bound value, but we are going to say that inside this, the true, in this case, it would be the true mean of the population, is in this interval. And we're going to say we're confident in that. We're going to be pretty confident in that right there. So we talked about some definitions here. The number that we use for the center of this interval, this number here, we call this the point estimate. Now, it could be a mean, it could be a proportion. It just depends on what that is. The distance from the point estimate to the upper bound, or the distance from the point estimate to the lower bound, that distance is called the margin of error, right? So that's what part of that is right there. So we got a point estimate with a margin error that creates a confidence interval, right? So that was some of the vocab that we used earlier on here. Let's talk real briefly about what is it that we're looking for when we do a confidence interval, okay? So in a confidence interval, there are three different kinds, right? So really it's a proportions, or it's a means when population standard deviation is known, or let's see if I can keep this going here. It's a means when population standard deviation is unknown. So we use the sample standard deviation in its place. Okay, so those are the pieces that we know. Now, with each of the three styles, I want to think through the different pieces that we want to make sure we know how to do, and that is called panic, right? Very, very much is really the A, the I, the C, but let's talk real quickly again about what is P. P is the parameter of interest. So that's to identify, are we talking about population proportions, population means, right? What is it that I need? Because that is your first goal when you get into this thing. Second piece, assumptions. What assumptions do I need to check in order to do proportions or in order to do means, right? We have a naming the interval itself, right? And this is really just to keep us on the right track so I know where to go in my calculator, know where to go when I'm doing the things I need to do. And then we get right into the interval calculation and right into the conclusion here, all right? So I want to really focus for a moment on the assumptions, the interval calculations, and the conclusion here, okay? So let's do that. All right, so let's focus first on proportions. Proportions. What are the 3 assumptions that we need to check? So I'm going to talk about assumptions, right? There's 3 assumptions that we need to check. Proportions are built on a normal curve. So we need to make sure that n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10. Now, if you aren't given a p-value, which is usual, use p hat. You always use the next best thing. If you're given p, use it. If you don't have p, use p hat. If you don't have a p hat, use 0.5. Okay. Second, we need random. We got to have random. Random sampling, random selecting, random something. It's got to be random, right? That keeps it unbiased. And then number 3, we're usually going to check the 10% rule. The reason we're going to check each of these has a check, right? So check normality. Check for unbiased nature. And then this one, check that standard deviation will work. The calculation will work, right? So that's for the standard deviation. That's for the centering up or the biasness. This is that we got to use the normal platform that we use for proportions. Okay, so there is the A. Let's look at the I. Let's talk about what does that formula look like. Remember, the formula is, since we're talking proportions, p hat plus or minus z star, that's the critical value that we need to go look up on the table, times the standard deviation of proportions, which if you recall, it's going to be p hat, 1 minus p hat, all over n. Everything's underneath that square root, okay? And then conclusion, I'm actually going to write out the conclusion here in a minute for all of them. So that's proportions. What is it that I use in my calculator? So I'm going to say my calc. Remember, you're going to go to the stat, test, and you're going to be looking for 1 prop z interval. I think it's just int though. Let me just double check. It's it only has, yes, 1 prop z int. So you need to make sure that you're using the word prop because we're doing proportions. It is z because it is always normal. Z means normal. And then int is short for interval. 1 prop z interval. That's my calculator that will do the work for me here. Now, your job's still going to have to be show all this stuff. All right, let's talk about means when the standard deviation is known to us, right? So what assumptions do we need to know? Number 1, if this is known to us, then we are doing a z distribution, a normal curve, right? So that's the standard deviation of the population. Just make sure you remember that, standard deviation of the population. That's what that symbol is, that theta symbol. So what are we looking for? Is n greater than or equal to 30? Because at that point, central limit theorem guarantees it. Okay, so that guarantees that's your normality check. Or the only other option we have now is the population approximately normal. If so, ching, we're good. If not, we're going to have problems. If one of those two doesn't check out, we're going to have problems, okay? So now, what does the interval calculation look like? Whoa, I am jumping way ahead, but that's because the other ones are all going to be very much the same. Random, I need a random nature, and I need a probably 10% rule because we are having to pull out of a population and violate independence. All right, let's look at the interval calculation. Here we go. If standard deviation of the population is known, then we're going to go x bar plus or minus z star times standard deviation of the population divided by the square root of n. Okay, that's what that's going to look like. Now, if I'm going to use my calculator, what am I going to put into my calculator? In this case, you are just going to do a z. I'm just going to double check. It literally has the whole word interval. Z interval. So again, z meaning I am doing a z distribution, interval meaning I'm doing a confidence interval, And for some reason, the calculator doesn't put Z mean interval like they did prop Z interval. They just say Z interval. You just need to know it's for means. All right, so there's that one. All right, let's do one other one. What happens if we're doing means when the standard deviation of the population is unknown? So we use S in its place. So now we are doing a thing called a T distribution, right? So now that changes some things up a little bit. So then we have the assumption checks, right? Number one, if n is greater than or equal to 30, we don't say central limit theorem. Central limit theorem guarantees normality. We say T distribution is robust, right? Robust is that word that kind of is the same thing that says it can handle extreme values and it's going to be okay. Or if n is less than 30, then look at the data set to be sure no outliers. Number two, no strong skew. Right? Since it's not robust when it's small, then outliers and skewness really mess up our data. Right? So we need to make sure that it's still going to be appropriate. It doesn't have to be perfectly normal looking. We just can't have outliers and strong skewness to it. Right? And then two, still go for the random. And three, let's do the 10% rule on here. Interval calculation. Here we go. X bar plus or minus T star, T critical value, we got to go look up because I had to use the sample standard deviation. That's why I'm going to put an S there in its place. So see how those super, super duper close to what you did earlier, just small modifications. Calc, we're going to go find T interval in our calculator, and we're going to do that to calculate that. We'll do Z interval to calculate that. We do one prop Z interval to calculate that one. And that does the algebra, the calculation for you, that you don't have to actually do that piece of it. All right, so that's what that is for. Just remember when you go to look up critical values for T, when you're looking up critical values, you are going to need to know the degree of freedom, which is n minus 1. Because you have to always convert to degree of freedom first, then go to its confidence level. Then you may get the right critical value on that one, okay? So that's what those are all there. And then let's just go ahead and do a nice strong conclusion. It's going to say we are blank % confident that the interval from blank to blank captures the true, and then I am just going to put this, the true parameter. So the parameter is either going to be the true proportion or the true mean. And then I'm going to also say context, because you are going to have to then supply the context. What is this going to? Now this is the conclusion we would use for proportion. We would use it for this. We would use it for this. It works all, it's that same thing. As long as we change the parameter to either be proportion or mean, change the context to be whatever is that particular piece of it. Okay, so that's what it is right there. That's the bulk of what we need to be able to do. Now, there are some problems where we have to work backwards on these, right? So if I'm going to work backwards, working backwards is all about the margin of error. Remember, the margin of error is the distance. So if I really highlight in on this, the distance is the thing that comes after the plus or minus, right? So this is how those work, right? So they're always going to give you a margin of error. So if it's for proportions, it's going to say that you're going to have a margin of error. So you would go and you'd put margin of error, and you'd say that it is going to be less than or equal to some value, right? So they might say 2%, 10%, 1%, 5%. It doesn't matter what margin of error they use. You're just going to plug it in. So if they gave me proportions, what do I need to do? I'm going to have to go look up a Z star based on the confidence level that they give me, right? A 95% would be 1.96, right? A 99% is going to be different. 90% is going to be something else, right? It's just going to determine. If you're given a p-value, plug it in here. If you're given a p-hat value, instead of a p, plug it in there. If you're given no value given, use p-hat equals 0.50. You're always going to use 50%. 50% is the most conservative value you can plug into this thing, right? And then they will give you a margin of error to use here, right? So that's what that looks like on that piece. If they have a different one and they're talking about means, typically for means, they're gonna give you the standard deviation of the population. So it's gonna be z star times standard deviation of the population divided by n. That would be, now we have the margin of error written, it's less than or equal to some value that they would give you. They might say we want the margin of error to be less than 5. Put 5 in there. Less than 8. Put 8 in there, right? Whatever it is. Go look up the z star based on whatever confidence level you are, and they will supply you with a standard deviation. And then you just have to work some magic. I mean, math. Did I say magic? Math, in order to get the actual answer that you need. Okay, so that's a real big majority of everything that we're doing in here. So the one last thing I do want to just make sure I separate here is, what is a confidence interval versus a confidence, oops, let's do that again. Confidence level. The level versus the interval. So let's talk first. The interval is literally the interval that we create. That is a lower bound and an upper bound. And what I would do is I would present this one physical interval, and I would say that we are, let's say it's 95%. We're 95% confident that this interval right here that we're doing captures the true population parameter. That's what a confidence interval is. I created one, and I believe that this is the one. This is one of the ones that captures it, and I got a good one here. So what is the confidence level? The confidence level says, if I'm out there in a population and I am looking for the true mean value, and I decide to do a confidence interval. So I do a confidence interval, and I go find a sample mean, and I build a confidence interval, right? So I go do that. But then if I go back into the same population, take the same size sample, and do this exact same kind of creation of a new confidence interval, it might actually look a little different, right? It might just change slightly than the one that I just did. And then I could do another one and build an interval, right? And then I do another one and I build an interval, right? And so on and so forth. And I'm going to keep doing this over and over and over again, right? So if I was 90% confident, right? So let's think about being 90% confident. And I'm going to build, like, I would have to build a bunch of these over and over and over again, right? 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and do 9. And let's say we got 10. Okay, so if I was doing a 90% confidence interval, but I was going to do it many, many, many times from the same population with the same size, what we'd say is this number, this confidence level, tells me how many of those intervals would actually capture. Like how many would? Like, check out this one. Whoops, that one missed, right? So every once in a while we'll miss one, but so 9 out of the 10 intervals should have captured it. 90 out of 100 intervals should capture it. 900 out of 1,000 intervals should capture it, right? So you get the point, is if you keep doing intervals, it tells you how many intervals actually capture it. So that's the confidence level. It's going to tell you how many intervals would actually capture it. And then the confidence interval is really on a very specific basis saying, I just calculated an interval and I believe this is one of those 90% that capture it, right? It's much more likely that this is one of the ones that capture it than one of the ones that doesn't. That's why we say we are 90% confident that this one captured it. So the interval is the physical interval. The level would tell you, if you did it many, many times, how many would capture it. Okay, so there you go. That is the stuff you will be tested on. Obviously, the knowledge behind it and then the creation of it using Panic.